In this video, we're going to discuss another way of visualizing sets. So this is Venn diagram, our 7th lesson for this chapter. So this chapter still talks about, chapter 1 still talks about sets, and the one of the best way to see the relationship of two or more sets is to really show them using display those sets using a Venn diagram. So this is basically by James Venn. Then we have here, if we're going to draw a Venn diagram of this set, so we have our U. So again, recalling that our universal set U is the biggest set, or the entire set, the set that contains all other sets under discussion. So A is contained in U, as you can see. So U, the elements of U are 1, 2, 3, 4 until 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that signifies that that is continuous until 10. Then we have also set A, 2, 3, 8, 9. Notice that A is a subset of U. Okay, then B is also a subset of U. So in this case, we're going to make a Venn diagram out of this. But looking at this, we need to compare first A and B. Do we see any common elements? 2, 3, 8, 9 and 1, 5, 7. There are no common elements. That makes us we draw two separate circles. Okay. So first, we draw our rectangle. This rectangle represents our universal set. This one. Okay. That one. So we say here U. Okay. Then since there are no common elements between A and B, we write two separate circles inside. Okay, so we write this as set A and set B. Then we write all the elements for A inside the circle. We have 2, 3, 8, 9. Then in B is 1, 5, 7. How about the other elements, such as, let us say, 4? Since 4 does not belong to A and it does not also belong to B, but it does belong to U, we write it outside the circle but still inside the rectangle, to mean that yeah, it's still an element of the universal set, which is the rectangle, but it's not an element of either A and B. So we say 4 here. What else? 6 and 10. Okay, so we can write anywhere as long as it's inside the rectangle. So this means, as you can see here, the element 2 in A, it's an element of A. It's not an element of B, but it's also an element of U. Okay, and 7 7 is an element of B. It's not an element of A. It's an element of U. Okay, 10 is not an element of A. It's not also an element of B, but it's an element of U. Okay, so this is how the first way to show the relationship of sets using a Venn diagram. The second one is this one. Notice that let's draw first our rectangle as our universal set. Okay. Notice that there are now common elements between A and B. So we have here, we have 5 and 7. Okay. So in this case, we draw two overlapping, the part of a circle are overlapping. We say here. Okay. And we write that as A, set A, and set B. The overlapping part, this one, we will write there the common elements. Okay. And that is, those are 5 and 7. Okay. Then we go back to set A. 5 and 7 is already taken. So we have 1, 3, and 9. Okay. So as you can see, the elements of A now are 1, 3, 5, 7, 9. For B, the remaining are 4, 6, and 8. Okay? So in this case, we have also other elements not in either A and B, and those are 2. What else? And 10. 2 and 10. Okay. So again, 2 is not an element of A, it's not also an element of B, but it's an element of U. 9 is an element of A, it's not an element of B, but still it's an element of U. 8 is an element of B, but it's not an element of A, but it's still an element of U. 5 is both an element of A and B. It is also an element of U. So this is the second way of visualizing the sets using a Venn diagram. How about the third one is that we have here. You have the universal set, 1 to 10. We write that here. Notice that B, all of these elements in B, you can actually find it in A. Okay? So it seems that going back to the lessons about subset, B is a subset of A. Meaning all elements in B you can find in A. So how do we draw circles to that? How can we display that using circles? So since B is part of A, it's like that. It's like saying part of A. All elements of B are in A. So we can just write a big circle. That's A. Then inside the circle A, we have a circle B. Okay. And that those elements of B are 4, 5, 6. Then the remaining 4, 5, 6, we have 1, 2, 3. Okay? Then the remaining again is outside the circles but still inside the universal set or the rectangle. We have 7, 8, 9, 10. So that is the third way of visualizing the relationship of sets using a Venn diagram. So now, we will use Venn diagram to answer the operations on sets. Remember, we have 4 operations on set. Now, the first one is the complement of a set. That's the here A complement. Then we have the difference of set. Here is the A minus B. Then we have the union of sets. So we have the A union B. Then the intersection of sets, this is basically in lesson 6. Okay. So here we say A complement. We list down the elements of A complement. Okay. So but going back again, these are still if you want to list down the elements of A, you have 1. No. 2, 3, and 5. Those are the elements of A. The B, 5, 6, and 9. How about the U? The U is from 1, 2, 3, then until 10. Okay? So, the A complement, it says that what are those elements in the universal set? That's the always. So, it's important that we understand the basic terms, the basic definition of these operations. So when you say A complement, what are those elements in the universal set, in the rectangle? What are those elements in the rectangle that you can't find in A? In the rectangle, but not in A. You can find them in the rectangle, but not in the circle A. So this is A and this is B. Okay? So what are those? So we have 1, you can find that inside the rectangle, but not in A. 4, 6, 7, 8, 9, 10. So as you can see, these are the elements that you can find in the rectangle, but you cannot find them in A. And those represents the elements of A complement. Okay? Set of all elements that you can in the universal set that is not in A. How about A minus B? A minus D is somewhat the same with A complement. It's just that it is relative to B. If A, we compare it to the universal set, A minus B, we compare it to the set B, to the other set. Okay? So A complement states that in this one, states that what are those elements in the universal set that you can find in A. That's 1, 4, 6, 7, 8, 9, 10. On the other hand, A minus B states that the set of all elements in A that you can find in B. Okay? sets of all elements in A that you can't find in B. What are those elements in A that you can find them in B? Of course, 5 is an element of A, but you can still find it in B. It's both an element of A and B, the 5. Therefore, our only elements for A minus B, elements of A that which are not in B, are 2 and 3. How about A union B? So we simply combined union, from the word union, we simply combined all the elements of A and B. That's 2, 3, 5, 6, 9. Okay? How about intersection? When you say intersection, this symbol, these are the common elements between the two sets. What are the common elements between A and B? That is simply 5, which is this one. Okay, so that's the basic. Okay, so you must be able to understand the definition, the basic meaning of these operations, so that when you translate it into your own words, you should be able to list down the elements from that Venn diagram. Let's proceed with a little bit more difficult problems. So you have here still our U here. I guess this is still 1, 2, 3 until 10. Okay, then we have our A as our A are 2, 3, 4, 5. Remember that 4 and 5 are common elements of A and B. B 4, 5, 6, 7, 8, 9. So this one is not necessary to list down, but it may help you. Okay, it may help you in listing down number 1. So what does it mean by this number 1? The complement of A union B. The complement of A union B. Going back to A complement, this one state that complement means what are those elements in A which are not, or what are those elements in the universal set which are not in A. So the same idea here, what are those elements in the universal set that you can find when you combine A and B, because union means combine. Okay, what are those elements in the universal set in the rectangle that you can find in the rectangle, but you can find them in both A and B, combination of A and B. So of course, that's 1 and 10. See? So you can find 1 in the rectangle, you cannot find it in either A or B. And 10. So that's the complement. How about A intersection B complement? Meaning, what are those elements that you cannot find in the common, in the intersection? What is the intersection? 4, 5. Okay, so what are those elements aside from 4, 5? So that's all other elements that you can find in that intersection. So that is 1, 2, 3, 6, 7, 8, 9, 10. Okay. So when you say A complement, this number 3, I think there's a need for us to get first the elements of A complement. A complement elements in the universal set, not in A. So what are those? That's 1, 6, 7, 8, 9, 10. Then B complement is the same idea, elements in the universal set that you can't find in B. What are those? That's 1, 2, 3. Okay, 1, 2, 3. That is 10. Okay, cannot find them in B. Now A minus B means A complement minus B complement, meaning that's the difference between the A complement and the B complement. Going back to this idea a while ago, A minus B means what are those elements in A that you can't find in B. The same idea here, what are those elements in A complement that you can't find them in B complement? And that is 6. You can find 1 in A complement, you can also find it in B complement. 6, you can find it in A complement, so you write that down here, 6. Then 7 as well. Okay, 8 as well. 9 as well. 10, you can find them in both, in A, but you can also find that in B. So that is not the difference. So that is 6, 7, 8, 9. So that is how we list down the elements of this a little bit complicated operations, combination of other operations using this Venn diagram. So how about we don't have any elements, we just simply try to shade the region which represents our given sets. Suppose which region are we going to shade? Okay, which region are we going to shade if um, we say the union of A and B? Which region there, if we're going to combine A and B, which region are we going to shade that represents all of this A combination of B? It means that's all. That's, we shade this. Okay, so this one, this shaded portion represents our elements when we combine A and B. Okay, union means combination of A and elements in A and B. Next, we have here the intersection, meaning the common. This symbol, that's the common elements between A and B. What's that? This is the region that we actually try to do. Okay, number 3. Oh, A intersection B complement. A intersection B complement. So what is that? Which region? What does it mean by A intersection B complement? All other elements outside the intersection. Okay? All other elements outside the intersection. So we shade all aside from the intersection. So the rectangle is also included. So this one gives us an understanding of, okay, so we shade all, practically all, aside from this intersection. So all of this shaded, this represents all the elements of this. Okay, meaning a complement of the intersection, meaning what are those outside the intersection, what are those elements outside the intersection of these two sets. Okay, so that's it. So that is how we try to use Venn diagram in solving problems related to sets. Next time, we are going to solve problems involving sets, not just Venn diagram. So Venn diagram is a tool, but in our lesson 8, we will be trying to solve really problems that worded problems, maybe worded problems, or just simply any problems that can be solved using operation on set or whatever other concepts related to sets.